Hi everyone, welcome to another edition of Take Charge Math. Be sure to check the reminders on the right for you to be guided accordingly. Our instructional video is divided into three parts: a quick review, an in-depth discussion, and a short quiz. So I hope you're ready. I'm excited. Let's get started. For our quick review, let us solve for the value of x on these equations. You may pause the video while you work on it. Good luck! Now let's check your answers. Let's recall the steps for solving a linear equation in one variable. Step 1. Simplify both sides of the equation. Number 2. If applicable, use the addition or subtraction properties of equality to collect the variable terms on one side of the equation and the constant terms on the other side. Third step, if applicable, use the multiplication or division properties of equality to make the coefficient of the variable term equal to 1. And lastly, for verification, check your answer by substituting your solution into the original equation. So, did you get the same results? For our today's topic, we will illustrate rational algebraic expressions. Let's do it! A rational algebraic expression is nothing more than a fraction in which the numerator and/or the denominator are polynomials. It can also be defined as a quotient of two integers, since the corresponding variable has a value. Here are some examples of rational expressions. The last one may look a little strange, since it is commonly written as 2c squared minus 4c plus 8. However, it's important to note that polynomials can be thought of as rational expressions if we need to, although they sometimes occur. There is an unspoken rule when dealing with rational expressions that we need to address. When dealing with numbers, we know that division by zero is not allowed. Well, the same is true for rational expressions. We will always assume that whatever the value of the variable is, it won't result for the denominator to be equal to zero. We rarely write these restrictions down, but we will always need to keep them in mind, and this will be our focus for today's topic. We will evaluate the rational expressions by identifying the value of the variable that will make it undefined. Let's start. For our first example, let's work on 7 over x plus 1. The general rule in determining the value or values that will be excluded in the expression is to set the denominator equal to 0 and solve for the equation for the variable. Please take note that we will only deal with the denominator. Alright? That will become x plus 1 is equal to 0. Then, on the left side, we apply the subtraction property of equality to eliminate positive 1, so that variable x will only remain. X now is equal to negative 1. For our final answer, we therefore conclude that x must not be equal to negative 1 so that the expression will not become undefined. Got it? Let's try another one. For our second example, let's solve 20a cubed over 12a. Again, we will only work on the denominator by setting it equal to 0 and then solve the equation for the value of the variable. That will become 12a is equal to 0. Then, we multiply both sides with 1 over 12 to eliminate the coefficient of variable a. Doing so, a now is equal to 0. For our final answer, we therefore conclude that a must not be equal to 0 so that the expression will not become undefined. You're doing a great job. Let's work on our last example. For our last example, let's solve b plus 7 over b squared plus 4b minus 21. In this case, we have a quadratic equation as our denominator. We follow our guideline by equating it to 0. Then, we apply the concept of factoring. When we factor b squared plus 4b minus 21, what do you think is our answer? By solving it, we will have b plus 7 times b minus 3. After getting the factors, we equate both to 0, and that will give us b plus 7 is equal to 0 and b minus 3 is equal to 0. Then we both solve for the value of b. B now will have two answers. B is equal to negative 7 and positive 3. For our final answer, we therefore conclude that B must not be equal to negative 7 and positive 3 so that the expression will not become undefined. And we are almost done. Remember that you may play this video over and over so that you'll have a better mastery of the topic. Now let's proceed with our practice problems. For our short quiz, I want you to try to answer these problems. You may pause the video for a while to give you ample time. Alright, good luck! Now let's check your answers. Did you get the same results? Congratulations! Thank you for your active participation. I hope you learned a new skill again on this video. You may watch it over and over again to give you a good grasp of the competency. Also, for additional mathematics resources, you may subscribe on my channel so that I can better assist you in your journey. Again, thank you very much and see you soon.